Hello everyone, welcome back to SAT Math Question of the Day. So here's the question. Please try to do it, pause it, and then come back and we will show you hopefully how to do it or offer ways to do it. Okay, here we have a graph. Population in millions of Florida over time, year since 1900. The scatter plot shows the population of Florida P in millions from 1900 to 2010, where T represents the number of years since 1900. Which of the following exponential equations best models the population of Florida from 1900 to 2010? So, first this is a 1. So the beginning number is the initial number is either 0.7 or 0.5.
Yeah.
So that looks
I was attracted first
by
the fact that it's growing.
Yeah,
and therefore growing. These two choices are ruled out because the exponent is less than 1.
Very good. Right. Oh, yeah.
Right? Yeah. And then I look at the remaining two.
Right.
And I see that the coefficients are equal.
Yeah.
Differences in the exponent.
Right.
So that leads me to just solve the problem by, say, picking one of the values, plug into the calculator, right. 5300 times, pick one of them. I would guess 1.41. Put it into the calculator, raise it to the 100ths.
Okay, so I can do
and
that.
See whether or not the result you get is 16.
Up to the 100th.
See if this is
times 0.53.
16.
No, it's only 4.
If this is greater than 16, then I pick C.
Yeah, it's
if
only
it's equal
4.
to 16.
It's only 4. It's only 4. It's only 4. So this is equal
And if it's less, then I pick this one. So this is, I'm trying it out. And what answer do I get?
4.
It's 4. So something's wrong.
Something's wrong. So 1.41. That is a 1.41, all right. And that is 100. Yeah. And you get a 16.
To the hundredths. Did you raise it to 100?
So. Yeah. 1.41. Yeah.
And you have to multiply it by 5.3.
Up to the 100th power.
Yeah.
Yeah, but okay, I have a mistake. My calculator is doing something real. Oh no, 1.41 up to the 100th power is 8.53 times 10 to the 14th. Oh yeah. This is in millions.
Oh.
Times 0.53.
Oh, millions. Oh,
yeah.
Gosh.
Yeah. It's 4 times 10 to the 14th. 1.41
so 2 times
to the 100th.
Yeah, 2. So if the exponent was 1.41, then we get 10 to the 14th, which is way out of it's ridiculous.
So
ridiculous for a human population.
So let's try 1.
So it must be this one.
Yeah, 1.035 to the 100th is more reasonable. That's only 31.
Yeah.
And 31 times 0.53 is 16. So that is the answer.
Okay.
Yeah, in some ways, when you said 40% growth, which is what this is, I said, wait a second, 40% growth.
No. Okay, that is very, very close. Yes, you had a much better insight to realize that, see, T is in years. T is in years. And this represents 41% growth.
Right. Yeah, which is ridiculous.
Per year.
For a human population.
For a human population is utterly ridiculous.
That's right.
And this represents 3.5% growth. So we should have, in fact, they wouldn't even have to show the curve. You could answer this without even seeing the curve.
Right. Yeah. Okay.
Yeah.
Yeah. That was good though, Seth. That you immediately went for the less than or greater than one. I was stalling on the 0.53 thing.
Okay. That's
But
because mathematicians know that the exponential feature of a function is a more notable feature
mm,
than 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 uh, than the linear property of the function.
right, you
That
mean the
you know,
start?
that's asymptotically
Yeah.
exponentiation beats linear by a long shot.
Right. So, in other words, Seth's saying that the initial value really doesn't matter when things grow exponentially, because
Yeah,
because
yeah,
if it's a little bit, you just wait a little longer, and the exponential will make it go up. And if it's
yeah,
a lot, if it starts at a
mm,
lot at exponential, well, then it's hopeless.
yeah,
Hopeless growth. Okay.
yeah,
So I think that's good. That's good. So I think we're done.
yeah, yeah.
Yeah. Yeah. Okay, we both sort of stumbled around a little, but that's normal. I mean, that's how we do math. So let's clear all drawings. Let's stop
Okay.
this thing.
Well, I think leads to an approach
Okay. So let's.
some problems.
Yeah.
Uh, will be solved with that an approach to us to check or investigate whether the choices are reasonable
Mm,
or the choices are realistic
yeah.
or make sense
Right.
in the context of a problem that you have some some qualitative understanding.
Yeah, that's true
Like
of all word problems.
so the figures so see and then what my advice is to be more careful and pay attention to the fact that the scale is in millions.
Mm, yeah.
So, and then that population of again, now, so background information from living in the world in the United States is that Florida is a state. Florida is being a state. It's a pretty big area. Its population has lots of people. It's comprised of several big cities and a lot of thinly populated land, and so millions, tens of millions, approximately. So the order of magnitude of such as of the population of a state like Florida is in the order of 10 million,
Yeah. Yeah.
right?
Yeah. Yeah. Yeah.
And
Yeah.
so this is a realistic plot, and so a real so and so you could just look at the choices and observe that it's in millions. So the coefficient says that in year zero
Mm,
is the first year when the graph starts,
mm.
1900, the population was about 500,000,
Right. Right.
and it grows exponentially.
Yeah.
And the reasonable growth rate for a healthy human population is about three. It could be a few
Yeah.
percent per year.
Right. Right.
Which means about 1 in 25 people. There's one baby born for every 30 people or so per
Right.
year.
Right. Yeah.
Random group of 30 people, and typically one of them. Yeah, a good guess. So pick 30 people randomly: old people, new people, old people, young people. Back of the hand guess is that oh, one of them will be pregnant
Yeah.
within that year or had a baby.
Right. So
Well,
basically, Seth's saying just common sense.
Yeah.
But I mean, in some ways, the equation took care of it because the equation is in millions. My
Yeah.
mistake was when I read
Well, the
off the
equation
four.
certainly takes care of it, but
Yeah,
if I'd been more awake and approached it with common sense, I might have picked the answer a lot quicker
right,
without having you put it into the calculator and get that ridiculous number
right,
for a
because right,
population of 10 to the 14th.
right, because I didn't. Well, first of all, I just said 4.4 because I didn't notice on the calculator. I didn't notice the little e, the little exponential thing. I just
Yeah.
completely ignored it.
Ah.
So 4.4
Ah.
made no sense, which means when you're
Yeah.
doing a word problem, you always have to keep in your brain has to work in parallel and always ask
Yeah.
at every point, does the number make sense? Does the number make sense? Does the
Yeah.
number make sense? And when the number
Uh,
makes sense, you stop and you say, what am I missing? And this made no sense at all, just getting the number 4.4. If they were really nasty, they would have made it so the coefficient of the exponential answer, the one with the 40% growth, would have been in line with the 16. But actually, that wouldn't have happened. That only would have happened in one spot. So anyway, we sort of we
yeah.
sort of blew it a little bit. But yes, yes, you could have done this problem a lot faster. So as usual, we are humbled. So let's see how they did it. Uh, so let's clear the drawings. And then stop this, and then we think the answer is this one, right? We only think it true. We both got the same answer, Con and us, and let's see how they did it. So 4 steps. Whoa. Wow, four
Ah.
steps. That's a little overkill. My
Yeah, it's
goodness,
overkill.
that's a little overkill.
Come
Hold on.
on. Come on, man.
Yeah, well, get upset. Let's not be so smug. I mean, we sort of did it a little slow ourselves. Since
Yeah.
the question asks for exponential model, okay, fine. So we know that, right?
Okay. No, well, no. Let's give it the benefit of the doubt. This whole stuff, this whole paragraph, uh, is a review
Right.
of the facts that I made use of right away.
Yes. Yes, it is.
So,
Yes.
if you as a viewer of this video, if you did not follow about what I said about the growth is it is growth rather than diminution,
Hmm.
and it's exponential.
Right.
Therefore, the coefficient is greater than one.
Right.
If that doesn't that doesn't connect with what you know right away, then it's important for you to prepare for the SAT to study those 3 paragraphs, because these 3 paragraphs teach. They expound in the way math, the way a teacher would teach it.
Yeah.
Those mathematical facts.
Right.
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 So it's not a waste for them to put it down.
That is true. That is true.
Yeah. Okay.
Now, notice that they did it more efficiently than we did. They immediately noticed that the growth rate of 1.4 means 41% growth rate, which is too high. So they immediately got they knew exactly. They got the answer a lot faster. We did because they
Yeah,
used,
that way.
yeah, right, yeah. They just looked at it. They
Yes.
didn't test a number. Okay, and then that's it. And then what they did, and now when I go down, that's right. That's a good thing to do. And then what they did then is they wanted to confirm it graphically. Good observation. Right now, when I go down, your stuff's going to stay, but that's okay. Good observation. There it is. We can confirm by graphing. Right, we forgot that you on the SAT, on the digital side, which is what this Khan Academy practice is, you will have a graphing calculator at your on the computer.
Hmm.
So
Yeah.
if you graph it on your graphing calculator, you will see that it's close. We can also solve it algebraically. Oh, look at that. They're testing 65, see? What is that 65 thing? Oh
Oh,
yeah,
come
they're
on.
testing, right? You see, they're testing the point 65.5. Sort of like
Yeah.
what we did. That's exactly what we did. But they first got the answer, and then they're backing this up. Frankly, you won't have time to do
Oh,
this. Um,
oh. Well, if, oh, I see. You don't know what B is. Right, right. So the problem is to find B. Okay, what the first thing that taught us, the first approach to solving a problem in school is to use algebra to invert the relationship and get an answer. The answer equals B equals the answer.
right, the 10th
However,
row.
in more complicated and deeper applications of math, it's often better because you as a the dependence is so complicated that you cannot get a formula for the solution.
Right.
The method for solving it is to try different
Yeah,
values.
just try a point. Yeah, that's what we
And
did.
in fact, if the this method of solving things by trying points works very well if it's in one dimension. You could
Yeah.
use what's called bisection, or if you have a formula that we could take the derivative and get the slope, you could use Newton's method. And that's the way, you had a problem where the formula is much more complicated. Guessing and checking more efficiently. Use the result of guessing to make a better guess, and then repeat guessing
Wait,
is the way it's
it's
done
all
in
over.
reality.
No, you could you don't necessarily didn't have to do what they did. You could have done what we did, which is just take a point 50 and do
Yeah. Ah,
point
yeah.
73 50 no 1.035 to the 50th and see if it's close to 5.
Yeah.
Yeah, and that's all you have to do. You don't have
Yeah.
to solve this, but not that many people are gonna probably do this solving thing. It's too bad they didn't also offer the other possibility that perhaps it's faster just to test a point, which is an
Yeah.
approach, which is the approach we took, which is probably faster than solving the equation. Just test a point like we did. It wasn't
Mm,
a bad way. It wasn't a bad way to go.
yeah.
It wasn't the
Yeah.
best way to go, but it also wasn't a bad way to go. Okay, so I think we're done, right? And then wait,
Yeah. Good job.
we're not done. We're looking at the last step. So either way, we see that that's the answer. Okay, so we are. Let's just introduce ourselves at the end. Seth's a PhD in math from MIT, professor emeritus at SUNY Albany for many years. He's now retired. I'm Seth's brother Joel. I have a PhD in mechanical engineering. We offer different approaches to the problems. Seth's more mathematical. I'm more practical as an engineer. But I should, often that's the case. And we try to offer different approaches to doing the SAT math questions, and also we offer an approach to study for the math SAT, which is to go to Khan Academy. They have two courses. They have the non-digital course and the digital course. Take the course that's appropriate to you. Talk to your guidance counselor. And we try to meet every day. And please leave us comments. We would love comments because they give us feedback. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. Okay, I guess that's it for today, right, Seth?
That's it.
That's it for today. Okay, hope to see everyone tomorrow.